Hello everyone and welcome to our new section. In this section we will discuss another type of linked list, which is circular linked list. Now from this lecture we will dive into deep about this type of linked list. Firstly, let's quickly recap what is a circular linked list. As we mentioned before, circular single linked list is exactly same as single linked list. The only difference is that the last node in circular single linked list points to the first node. However, in case of single linked list, it was null. So as you can see from this picture that the last node is this node over here. The next reference of node in case of single linked list is null, but in case of circular single linked list, it points to the physical location of first node. So you can see from this picture that the physical location of first node is 001. So the last node's next reference points to this node over here. So basically, by pointing last node to the first node, it creates a circle over here. That's why it's called circular single linked list. So it's obvious that we can perform the operations that we have performed in a single linked list on circular single linked list as well. So in this section, we are going to perform them one by one. Now the first operation is creation of circular single linked list. So here again, the first thing that we are going to do, we are going to create head and tail references. Now when we are creating head and tail references, the reference of head and tail will be null. Then we are going to create a node and insert a value on it. Now in this case we have created this node over here. Now in our node the value is 1 and the physical location of node in the memory is 001. So in case of single linked list, we were creating node and then pointing head to this node and tail to this node over here because this is the only node that we have in our linked list. And the next reference of this node in case of single linked list set to null. But in case of circular single linked list, we know that the last node in circular single linked list has to point to first node. Now in this case we have only one node, which means that this is the first node and this is also the last node. So this means that we have to update the next reference of this node to itself. So we are going to update the next reference of this node to 001, which is the physical location of itself. So that's why this node points to itself in this case. Now the next step is we have to update the head reference to point to this node over here. So if we update head reference to 001, it's going to create a link between head and this newly created node. Then the last step is we have to point tail to this node as well. So if we update the tail reference to 001, it's going to create a link between tail and this newly created node over here. So with this, we are able to create circular single linked list. And when we are creating a circular single linked list, in this case, we have only one node. So this means that this is first node. This is also last node in our circular single linked list. That's why it points itself over here. So we cannot leave this next reference empty. We have to update it to itself. So that's why in this case, it creates a circle over here. That's why it's called circular single linked list. Now let's see how algorithm of this creation of circular single linked list works. Now here algorithm looks like this. So in this case, it starts from here. Then we have one parameter, which is node value, because when we are creating a circular single linked list, we are creating a node inside circular single linked list. So that's why we need a value for node. Then we are getting value from parameter and we are creating a blank node and assigning this value to this blank node over here. So as you can see, create blank node and node value set to node value that comes from this parameter over here. Now the next step is we are setting next reference of this newly created node to itself. So in this case, we are setting next reference to node. Then the next step is we are setting head and tail to point this node over here as we did over here. So after doing so, we are terminating our algorithm. Now based on this algorithm, we are going to create circular single linked list class in Java and we will implement create circular single linked list method there. Then in the upcoming lectures, we are going to implement all transactional methods inside this circular single linked list class. So let's head over to Java to create our circular single linked list class. Now here, the first thing that I'm going to do, I'm going to create node class because each element of single linked list or circular single linked list consists of nodes. So in nodes, we have value and next reference. So that's why I'm going to create separate class for nodes itself. So here I'm going to create new file and I will name it node.java. Now inside this Java file, I'm going to create our node class. So it's going to be public class node. And inside this class, we are going to have two properties. So the first property will be public int value. So in this case, our nodes will consist of integer values. So if you want, you can put over here string or other data types. In this case, I'm taking integer. Now the next property is going to be next reference. So the next reference should be the type of node. So I'm going to create it like this, public node next, because it's going to reference to the next node. So that's why I'm taking the type of node. Now with this, we have finished our node class. So basically it's very simple class. Here we have only two properties of class in which we are keeping the value and next reference to the next node. Now the next thing that I'm going to do, I'm going to create another class which will be the CircularSinglyLinkedList class. So here one more time I'm going to create another file and put it like this, CircularSinglyLinkedList.java. Now inside this Java file I'm going to create another class which is called CircularSinglyLinkedList class. So it's going to be public class CircularSinglyLinkedList. Then inside this class we are going to implement our all properties of CircularSinglyLinkedList and all transactions that we can perform on CircularSinglyLinkedList. For each transaction we are going to create separate method, so that's why it's going to be the properties of this CircularSinglyLinkedList class. Now the first thing that I'm going to do, as we mentioned before, in a CircularSinglyLinkedList we will have head and tail references. So this is going to be the type of node class, because these are pointing to the first and last node, so it has to be type of node. So first reference is head and the next reference will be tail, and both of them is type of node class that we created over here. Now I'm going to add one more property, which is going to be the size of CircularSinglyLinkedList, because when we are declaring the size over here, it makes to implement some other transaction easier. So whenever we are inserting a node to the CircularSinglyLinkedList, we are increasing this size. Whenever we are deleting a node, we are decreasing this size. So we have to keep the size of the CircularSinglyLinkedList inside this variable over here. Now after implementing common things, I'm going to implement create CircularSinglyLinkedList method. So in this case, this method will be the public node and the return type will be the node, because we are going to return head value. Then I'm going to name this method create CircularSinglyLinkedList. Then inside parameter is going to take one parameter, node value. So as you remember, in our algorithm we have mentioned that it's going to take one parameter, which will be the node value. Then I'm going to set head like this, head new node, and we are going to create blank node and assign this parameter value to this node over here. So it's going to be like this, node will be the new node, type of node. So with this we are creating a new node over here, which is with the small letter node. Then here I'm going to assign the node value to this node over here, newly created node. So this is newly created node, and the value of this node will be the node value that comes from this parameter. Now the next step is we need to set the next reference of this newly created node. So the next reference of this newly created node, in case of single linked list, was null, but in case of CircularSinglyLinkedList is going to reference to itself. So I'm going to put it like this, node next has to reference to itself, because this is CircularSinglyLinkedList, and when we are creating CircularSinglyLinkedList we have only one node in our linked list. That's why it has to reference to itself. Otherwise, if we put null over here, it's going to be single linked list, not CircularSinglyLinkedList. Now the next step is head and tail references has to point to this newly created node over here. So this means that head equals to node and tail equals to node. Then we have to set the size of this CircularSinglyLinkedList. So the size will be 1, because here we have only one node in our CircularSinglyLinkedList. So at the end, we are going to return head value. So with this, we have completed creation of CircularSinglyLinkedList. So with this method, we are creating a new node and assigning the next value of this new node to itself. Then we are setting head and tail references to this node over here. And then at the end, we are setting the size of this CircularSinglyLinkedList to 1, because in this case, we have only one element in our CircularSinglyLinkedList. Now inside main Java class, I'm going to create a new CircularSinglyLinkedList and to see that if our method is working properly or not. So here, the first thing that I'm going to do, I'm going to create the instance of this class that we created over here, which is CircularSinglyLinkedList class. So it's going to be like this, CircularSinglyLinkedList CSLL equals, so I'm going to just copy it from here and put it like this, new CircularSinglyLinkedList. Then based on this class over here, we are going to call create CSLL method, which is responsible for creating CircularSinglyLinkedList. Now in this case, it has to take a parameter of node value. So in this case, I'm going to put 5. Now how can we check that if this is working correct or not? So if we access the head value, which will be the first node's value, and printing out to the console, we can see that if this is created or not. So I'm going to print out to the console the value of head value. So in this case, CSLL.head.value. Now if we run our code, you see that the value of first node is 5. Now how can we know that if this is circular single linked list or single linked list? Now in this case, if we access the next reference of first node's value, in this case it has to print out 5 as well, because in this case it's referencing to itself. So what I'm going to do, I'm going to just copy this line of code from here and put it over here. Then instead of accessing the first node's value, I'm going to access the node's value which is referenced by first node. So in this case it's referencing to itself, so this means that it has to print out 5 2 times over here. So if we run our code, you'll see that in this case, first it's printing out first node's value, then it's printing out the node's value which is referenced by first node. So in this case, it's also 5 because here we have only one node in our circular single linked list. Now, with this, we have completed our creation of circular single linked list method. Now let's see what is the time and space complexity for this method over here. So as always, we are going to start from the first line of the method. In this case, in the first line, we are setting head to this new class, and then we are creating a new node using this node class over here. So these 2 lines of code will take a one-time complexity because here a time-consuming operation is not performed. Then we are setting this node value that comes from the parameter to the node value that we have created over here. Now this is just simple assignment statement, so in this case it's going to take a one-time complexity. Then in the next line of code, we are setting node to its next reference. So this means that it will take a one-time complexity because here also we are just doing assignment operation. Then we are setting head to this node and tail to this node. This means that these 2 lines of code also will take a one-time complexity because these are also the simple assignment statements. Then at the end we are setting size to 1 and returning head. And these 2 lines of code also will take a one-time complexity. Now if we combine all these complexities over here, we will get a one-time complexity. So this means that creating circular single linked list will take a one-time complexity. Now the space complexity is also O1 because in this case we are just creating a single node in the memory. So this means that when we are creating circular single linked list, we are just creating only one node. So our circular single linked list consists of only one node, so that's why the space complexity will be O1. Now with this we have come to the end of this lecture. So in this lecture we have learned what is circular single linked list and how can we create it using Java. So hopefully everything is clear about this lecture. See you in the next lecture.